Question number 10 says approximately 25% of the cars sold are red. Michael's observing cars as they drive by his house. What is the probability that he has to watch at least 3 cars go by in order to see one that is red? Well, this phrase, at least 3 cars go by, is somewhat complicated. So let me try to explain what's going on here. We want to wait until at least the third one. So here's the first car. I don't want it to be red. I want it to be something other than red. We'll take the fancy blue car that goes by. Okay, I don't want the second car to be red either. I want to wait at least until the third car, so here comes my second car. On the third one, if I have to wait till at least the third, then it could be that this is the scenario that, hey, I waited until at least the third one before I saw a red, which would be called a success for us. Success means we have to wait at least until the third car. But that at least is a little bit of a sticky wicket. What we want to make sure that we work with is this idea as well. At least means even if the third car, it may not be the third car, but I had to wait at least to the third car, at least means I could have had to wait to the fourth car before I got a success. And that's what would be called a success. But that isn't the only case either. We could also have to wait until, and this is what I hope I'm getting you to see, is if I keep trying to think of it like this, it could be until the fifth car before I finally find a red one. And this pattern continues on forever. So this gets to be a problem that you can't solve using this type of logic. So let me backpedal and see if we can figure out how to do this a different way. So differently would be, if it's hard to count the number of successes, since successes is somewhat difficult to count, let's see if we can count failures. So there's a direct link between successes and failures. Let's come back to the fact that red cars, there's a 25% chance of having red cars. So what's the chance of not, or being a non-red car? Well, if it's a 25% of being a red car, then that means there's a 75% chance of it being a non-red car. Now, I'm also going to work with some fractions. 25% is 25 out of 100, which is 1 out of 4. I'm going to choose to work with fractions here in a little bit. 75 out of 100 is 75%, which is 3 out of 4. But here's what I want you to recognize. The red ones are thought to be successes. When we see a red car, it is a success. When we see something that is a non-red car, that is called a failure. If we were to add the successes and failures together in any one of these equivalent forms, 25 plus 75 is 100%. Or 25 out of 100 plus 75 out of 100 is 100 out of 100. Or 1/4 plus 3/4 is 4/4. But in any one of these equivalencies, they're all basically equivalent to 1. So the point I'm trying to make on this, if I simplify, is that if you add up your successes and failures, so success plus failure always has to add up to either 100% or 100 out of 100, or just simply 1, which is what I'm targeting. So here's what I'm also trying to get you to see. If we take successes and we add our failures, we should always get 1. We were having a hard time counting the number of successes because success means we have to wait to the third, the fourth, the fifth, the sixth, and it kept going on forever and ever and ever. So successes were tricky to figure out. So in order to figure out successes, we won't calculate them directly. We'll calculate them by taking 1 minus your failures. So we'll take 1 minus the failure of having to wait 3 cars. So this will be a little bit easier for us to calculate. So now I'm going to come back and we're going to try to re-diagram what we need to have happen. We have to wait at least 3 cars. So the only way that we really fail is, here's our first scenario. We'll call this scenario or situation 1. So situation 1. What if the first car that goes by is red? So if the first car that goes by is red, that is called a failure. We did not have to wait until the third car to see a red one. So what are the chances that the first car going by is red? So I'm going to calculate the chances of failure. So the chances of failing in this, what failing means, I see a red in the first one. What's the probability of seeing red in the very first car I see goes by? And that is 1/4. The probability of seeing a red on the very first car that goes by is 1/4. So now I'm starting to figure out, that's failing in this case. So successes is equal to 1 minus how many or what the chances of failing are. Well, in the first case scenario, I've got a 1/4 chance of seeing a car that's red on that first drive-by. Okay, so here's another situation, situation number 2. This would also be considered a failure. The first car goes by, it is not red. The second car that goes by, it is red. This is a failure as well because I did not have to wait for the third, at least the third car. So what's the chances that the second car could be red? So the chances that the first car is not red is 3/4. The chances that my second car is red is 1/4, and the chances that the first car is a non-red followed by a red is 3/4 times 1/4, which is 3/16. So that's another opportunity to fail. So we're going to add up all of our chances of failing. This is if the first car was red, and now if it's the second car is red, and we have a chance of that of 3/16. Okay, so now let's go, is there another situation out there? Well, that should be all of our situations, because my next situation, situation 3, would be, my first one is not red. My second one, let's break down another one of these fancy automobiles, not red. And then I had to wait until the third one, and now it can be red. This means I had to wait until at least 3. So this is a success. I'm not counting those, so that's all that I needed right over here. So I'm going to close this bracket and say this is the probability that we will fail, that we will not have to wait 3 turns before we see a red one. So probability of success is equal to 1 minus 1/4 plus 3/16. We'll make that 4/16 plus 3/16. That's 1 minus 7/16. And that means it is 16/16 minus 7/16. And that means it is 9/16. There's a 9/16 chance. Well, they didn't give you answer choices as fractions, so if we take our 9 divided by 16, it equals 0.5625. So there's basically, if we wanted to write it as a 56.25% chance, it gives a little bit more meaning, but this is the number that they have for the answer choice. So a little bit of a different strategy, but hopefully I've kind of given you a reason why you need to use that strategy, because you can't count all the possible successes. You can only count the number of failures and then subtract from 100%.